page 91. During this unit, we will be using extremely large numbers and extremely small numbers in our calculations, which will require us to do the math and use numbers that are in scientific notation. In class, we talked about how to input scientific notation into your individual calculators. So here are steps that are a reminder. If you're not sure of how to do it or you don't remember, then you need to ask me about it. But here are a couple of problems that you can check yourself. So put in your calculator 2.37 times 10 to the 26, then hit your multiplication function and multiply that value by 4.1 times 10 to the 13th power. On your calculator, if you read out an answer of 1.07 times 10 to the 40th power, then you have done the math correctly on your calculator. If you can't get this value on your calculator, come and ask me for help so that we can work through the steps on your particular model. The next example, put 4.52 times 10 to the negative 8, hit your division button, and then put in 1.25 times 10 to the minus 4, hit your equal button. Now, depending on your type of calculator, if you get an answer that reads out, it should be less than 1, so it could read out as 0.000362, or your calculator could also give you this answer in scientific notation. So the scientific notation would be 3.62 times 10 to the minus 4th power. So if you get the decimal written out or scientific notation that looks like this, then you've put this correctly in your calculator. Try one more where you multiply the two top numbers, so 8.93 times 10 to the 25 times 18.021. Hit your equal button, then hit your division button and divide it by 6.02 times 10 to the 23. Hit your equal button again. So on your calculator, if you get an answer of 2,673.21, then you have put this math in your calculator correctly. So try these calculations, check your answers against these to make sure you're using your calculator correctly. So here we go. We use these really large numbers when we are counting particles. So here we go. The relationship, 1 mole of any substance will contain 6.02 times 10 to the 23 particles. Now, the count, it can be recorded with a variety of units. So for example, the most general one would be particles. It could be referred to as molecules. But if we are counting the individual particles present for a single element, then it could also be referred to as an atom. So once again, when you go to solve these and you have to show the work needs to be shown as dimensional analysis. So first example that I will do, it reads, how many atoms of copper are present in 2.50 mole sample? So here's my starting quantity. In this example, I need to go from mole to a count of atoms. So I'm going to start with 2.50 mole, and it's moles of copper, Cu. And I want to go from the mole to the number of atoms. and I want to be able to cross off the unit of mole. The relationship between these is this up here. It's 6.02 times 10 to the 23 atoms, so I'm going to put 6.02 times 10 to the 23 atoms in every mole. So in my calculator, I put 2.50 times this huge number, Avogadro's number, 6.02 times 10 to the 23. So when I write down my answer, my calculator answer, it's 1.51 times 10 to the 24. The math I put in the calculator, I have to do the same math with units. So when I take a look, I have mole times atom divided by mole. Since there's a mole upstairs and a mole downstairs, I'm allowed to cross it off. So this number, this huge number, represents the number of atoms, and it is specifically atoms of copper, so I label it with Cu. So just like the other problem, okay, taking a look at this answer, I have met all three criteria. I have my value, I have the unit in which it's quantified, and I know the substance that it belongs to. Those are all three parts of an answer. Okay, so let's take a look at the we do. In this example, it says determine the number of moles. So moles is my unknown. So determine the number of moles of NaCl present in 9.950 times 10 to the 26 particles. And this is a unit for count. So this is what I'm starting with, is a count of particles. So I have 9.950 times 10 to the 26 particles. And there is no abbreviation for particles, and it belongs to NaCl. I want to go from a unit of particles to the unit of mole, and I want to be able to cross off particles. So my relationship is 1 mole contains 6.02 times 10 to the 23 particles. So when I go and put this into the calculator, 9.950 times 10 to the 26 times 1 divided by Avogadro's number, 6.02 times 10 to the 23, what I end up with is 1,653. Now I need to do the same math with the units. I have particles times moles divided by particles. So since there's a particles upstairs and a particles downstairs, I'm allowed to cross them off. The only unit I'm left with is the mole, and this number of moles belongs to the substance of NaCl. So look at my final answer. It meets all the criteria once again. Okay? It shows the value. It has the unit and the substance that this represents. You go ahead and try. You do number 1 and 2. Check your answers with your teacher.